we're going to talk about pen testing, and pen testing from a different perspective. A lot of pen testing that's happening today is really for dummies. In fact, there are books, pen testing for dummies, I think. But we'll make it more complex, more interesting, and we'll explain, demystify a couple things. Throughout presentation, I'm going to give you actual practical hints what to try and what things you can do in 2023 to do pen testing successfully with actionable results. I'm going to introduce myself a little bit, tell you who I am. This is what I look like if I'm wearing a tie. But I consider myself an IT professional. Yes, I have an accent, and my native language is Russian, but I'm not from Russia. I was born in Ukraine great many years ago, and I in the United States since 1989. So this is my home. I never been a hacker. I've been an IT professional, and that was my initial calling. I began to try to understand how things work because of curiosity, natural curiosity. And as I progressed, I became a cybersecurity professional. Actually, a great time to be growing up in technology in early 2000s. I started questioning if even commercial software, is it written correctly, if it's bug-free, how things really work, and how to get further. In the past decade and a half, I really started watching how hackers work, how the minds work, and start hunting cyber criminals. If you Google my name, there are quite a few hits there about successes of me, my company, achieving really big victories against cyber criminals. One of the last things that we did that hit Forbes magazine was taking Bitcoin in half from Russian drug lords and moving it to Ukrainian charity. So we try to do good things and really use cybersecurity for the good stuff. But stopping cybercrime is very, very important. And my not only guilty pleasure, but the oldest cybersecurity skill that I have is penetration testing, pen testing. And that's what I'm going to be talking about today. I'm talking about a lot of history, literally more than 10,000 pen tests behind me and my team on companies of all sizes, from very small companies to million-plus device pen tests. So this is all from experience and really good hints from us. I'm going to tell you a story about my first pen test. It happened in 1997. Some of us maybe not born then, definitely not many been doing pen testing in 1997. This was also the year Nmap was invented, by the way. So I didn't use Nmap for the first pen test. I was very, very young. In my early 20s, I was hired by a relatively small company to do a security test. They had this new cool thing called firewalls. So I was hired to do it over the weekend, so not to impact the stability of computers that were regularly rebooting anyways by themselves. So did the pen test. I remember I got paid $500 for roughly 40 hours of work. That was normal labor at the time. But it was the first pen test that I've done, and it was so much fun and exciting. On Monday call with the guy who hired me, the IT manager, I told him about the results and said, hey, you guys, as far as I can tell, don't have a firewall. And the guy got really upset. He yelled at me on the phone and pretty much fired me. So that was my first pen test. But I got into the router, the internet router. I saw a number of hops. I didn't see extra hop. I didn't see any traffic filtering. I didn't see any ARP entries. I was relatively smart at the time. Didn't get better afterwards. But 2 weeks later, the guy, the manager called me and said, hey, they want to meet for lunch. And like, okay, well, you want to yell at me in person? Go ahead. So I came out and I didn't have a car at the time, so it took me a while to get to a place he went for lunch. And he sat down with me and said, "I found the firewall." So this is a story how what happened to the firewall. So the company, which spent quite a bit of budget at the time to buy firewall appliance, sent two guys in IT to get trained on the firewall. One of them got certified. One guy left within a month. Another guy left within 3 months. As the second guy was leaving and nobody really had any certification or really clue how to use that firewall, he was asked to put any rule on the firewall. So that, to make things more easy to support. But the first time they had a network problem, the brilliant network guys actually routed all the traffic around the firewall. Couple weeks later, somebody needed a network cable. That switch was full, so they took the network cables from the firewall and disconnected the firewall from the network. And then at some point, somebody needed rack space, and they removed that big black box that was taking 4 use at the time and put it in a storage room. That's where the manager found the firewall. So he said that technically they have a firewall, it's just not in the right place. So I got paid. The pen testing is not an easy science if you understand, if you ever done this. And I'm going to usher you through some challenges, some interesting things that are out there to consider what pen testing should be and really is. Penetration testing is not like compliance. Compliance to me is best practices, because if we don't have best practices, we're not going to do the right thing. If we don't have the rules how to drive, we all going to drive crazy. But we need to follow the driving signs and stuff like that. Or speed. So it's we know where to bend the rules. Compliance is to keep us within those lines. Vulnerability testing is also not pen testing, because vulnerabilities actually show you classical vulnerabilities, CVEs and stuff like that, but you're not going to discover things. Vulnerability testing is another type of assessment. It's a valid assessment, but it's not pen test. And red teaming, which is also a good way to do this, but the red team is more about capture the flag for me. Red team would go through tools available to them, but they are not always going to test everything. Pen test to me is about thoroughness. If you found one way in, good. You document it, you keep going to the next vulnerability. Red team is more capture the flag. They use one vulnerability to get in and they get further to show the impact. Pen testers, only if they want to show off, want to use that access to get much further. But the goal of a pen tester is to test all the ways in. Because I always say that hackers, when they attack, cyber criminals, when they attack your infrastructure, they are like pen testers. They just don't share the pen test results with you. They keep it to themselves. And also on the defenders, on the blue team side, we need to be 100% right, because bad guys only looking for one way in. And pen testers, we have a job to do this 100%, find as many vulnerabilities as possible. From that perspective, I want to talk about ideal pen tester. Who is a pen tester? I hire a lot of pen testers. We are hiring. We definitely look for certain things. I'm not only going to look at technical capabilities of person. They can be brilliant. They can win a lot of capture the flag exercises and stuff like that. But the question is, okay, do you know how things work? Do you have natural curiosity, or are you going to follow the step 1, step 2, step 3 of a pen testing manual, which doesn't exist in my head? So curiosity is extremely important. If you're curious about things, how things work, and then you have basic technical capabilities, you're going to be a potentially good pen tester. You need to understand technologies. I think technologies are the key. If you understand how technology works, you can take things apart. We have a different type of job. Some developers who don't really like pen testers because we really figure out things that they screwed up. But we need to be partners for these guys, because if we understand technology, we can find weaknesses in technology. If we have no clue about technology, about the protocol, about infrastructure, we're not going to be effective finding every single thing that's out there. Experience with system administration, how the network infrastructure works, how interactions work. A lot of pen testers come in and say, hey, I can break any web application. What about not web application? What about thick client? What about AD? What about Linux infrastructure? We want pen tester to be versatile. I mean, there are folks who specialize in certain technologies. By all means, you're going to end up doing that. But you're also going to be very good at everything, but you need to specialize in something. If you don't understand how the infrastructure works, you don't have much of a chance to be versatile. And then today, more and more pen testing is about developer skill set or about basic scripting. You don't have to be a full-scale developer, but you need to know how to do automation. Not being driven by tools, and we're going to talk about that more, but you want to be actually a developer, have developer skill set, and you can automate everything that you're doing. I end up in pen tests writing 2 or 3 of my own tools because I need to automate certain functions. Some of it is very simple, some of it may get more complex, but even if you're not a developer, if you're not good at scripting, you need to have a friend who is. And that way, in the team, you're going to be much more versatile. If you have a system admin experience, then your friend can be a developer, and both of you can do really, really cool pen tests. From the different types of pen tests, and we'll get into details just shortly, but there are different types of pen tests, and sometimes you're going to do one or the other. I want to explain the difference and why each one of them is important. Sometimes black box pen tests, when you are given almost zero knowledge, I mean, besides what you have to your target, it is a good thing. But it's not always an easy thing. It's probably imitating the real life the most, because the bad guy walks around the internet, they find your website, now they're going to be attacking it. That's pretty much the idea of the black box, without any additional knowledge, without any additional information. But there are some caveats and some weaknesses in especially today's infrastructure. In the gray box components, which is probably the most common type of pen test today, is when there is basic knowledge shared. Not only about what you're testing, but you're given some kind of user access. For the most part, most of the applications, most of interfaces today require some kind of authentication. And that authentication may be open to a smaller group of people, like employees. Some of these components may be open to anybody who wants to register. So if you can register, if you want to test certain functionality, you need to be doing it as a user on a deeper level, because the bad guys know how to register for things. Look at some of the vulnerabilities, some of the breaches that are coming out today. Somebody goes ahead and fills out information, hey, I want to register for access on that website. And somebody in IT and help desk says, oh yeah, approve it. Great. Now the bad guy is inside of your infrastructure, and they may have access on a basic user. Can that basic user own the system? We don't know, but pen tester can tell you. So make sure that when you talk about pen tests, you're not only doing complete black box, but you have abilities to look inside the application. And it's extremely critical to understand how things work there. The other type, probably more thorough, but different, is the white box, where you are given access not only to the front end, but to the back end, and you're going to do an assessment based on what you see on both sides. This is not realistic. The bad guys, if they have access to the back end, they already in, so they got all the data. But here's what you can do as a pen tester, as a good, experienced professional. You can look at what happens when an attack actually ensues. You can identify root cause of a problem. we deal with SQL injection still so many years later because of this vulnerability being out for a number of decades and still leaving certain things vulnerable. Well, to write SQL injection sequence is not easy, and even some tools are not smart enough to do this. But what if you can put a sniffer or logging agent on your SQL server, and you can, during your pen test, during your SQL injection attempts, you can see how many of your signals actually getting to the SQL database. Maybe it's not in the right format. Maybe you're not escaping every single sequence. Maybe the number of columns that you're trying to put in is wrong or whatever. But if the signal is getting across, it means it's possible. And the bad guy with a different approach, but with slightly different tools, can be successful. Same thing works on certain 500 errors. So sometimes you don't see other components what are out there. And my favorite is that when you see certain vulnerabilities, you may not react to them appropriately, but behind them may be much, much more information. It starts with a single file that may be exposed, and that may give the bad guy a file naming convention that you would not guess otherwise. So if you see the file infrastructure, you would be much further in. So white box has its own uses, but level of sophistication of that is obviously different. Scoping. To scope a pen test also takes a special skill. If you ever scoping your own pen test, if you're setting up, make sure that you are mentioning certain things. You can have internal pen tests, external pen tests, which are different pen tests, and make sure that you do the external pen test first, not internal, because with internal, if you're doing with the same guys, they're coming up with so much knowledge about your internal infrastructure that they may not have a fair advantage over the standard outsiders. So outside pen tests first, but inside should be also a consideration. Third party. Now we are within third-party space, whether it's cloud, whether it's you have a hosted application. Make sure that you test these things thoroughly, but you also need to make sure that you're obtaining proper permissions. Just because it's sitting in Azure, Azure has its own set of rules versus Google Cloud versus AWS and stuff like that. So you need to follow their rules. And breaking into the environments is different and sometimes not easy. If it's a third-party hosted application, you still can pen test. There still may be additional limitations, but you can actually request these tests to be on a different level. And then looking at the infrastructure. What are the components of the infrastructure that you need to test if it's going to be all or some specific components or applications? Because at the end of the day, most requests today coming in for pen test is a pen test is application. Besides this, here are the common mistakes that are given. Let pen tester to figure out. You know, we just got a request from clients saying, "Hey, here are 5 RRPs. You figure out the rest." Great, thank you. Well, at least you get that list, because we would not start a pen test without knowing the limitations. It's very simple to assume that everything on this subnet or within this domain belongs to a client. Sometimes it does not. And you definitely don't want to be breaking into somebody who is not related to a client. It's very easy to make that mistake and attack the wrong infrastructure. Plus, pen testers may not know every single component. They may not have all understanding of all the different components, what's out there. One of my least favorite things is a very, very narrow test scope, saying, hey, here's an environment, here's a test environment that you can do all your work in and don't do anything else. And also making sure that you're not doing tests with an empty system. Too many times our pen test scope is within a test or QA system. Here's what happens. Here's an issue with this. We, in 2006, the company I was working for decided to acquire McAfee's EPO. E-policy orchestrator. And this product was relatively new for McAfee, and we said, hey, can we do a pen test against your infrastructure? And they said, well, of course, we already did the pen test. Go ahead, see what we find. So we found over 100 vulnerabilities, critical vulnerabilities. McAfee EPO is really cool botnet if you think about it. If you take over, now you got agents on every computer that completely 100% trusted. You can run viruses on antivirus software because you can just exclude your signature on there. So why not? And it would do any command. It's impossible to shut down remotely. So it's really, really cool botnet. So we showed that to McAfee, and they said, well, no, you must be running old version. No, it's the latest one that you gave us. They came back, and a while later, the product owner, manager from McAfee called, and he said, hey, in our pen testing, we made a slight mistake there. When we tested EPO, it has a whole bunch of modules, like firewall, antivirus, stuff like that. When we tested EPO, we didn't enable any modules. It was completely, just a framework. And like, okay, fine, in framework, we found no vulnerabilities. Framework is good. But within the environment, when you are enabling features and functions, you need to be testing something realistic. If you're looking at lateral movements from user A to user B, make sure that the user A and user B actually have data. If these are just empty accounts, it's impossible for you to see user B's data because there is no data. And if there is no data in the system at all, there is no way to actually get into the system and retrieve the data because it's absolutely empty. So more and more you look, more you find that certain pen tests are always set for failure. I've been doing a pen test on a system where I'm the only user. Well, can I become another user? I don't know. There's nobody else to become. I can create a user. So make sure that when you test in the right place, in the right setting. Excluding environments also a bad idea because certain environments are similar. So if you can get into one environment, you can transfer knowledge from one environment to another. Sometimes QA environment is less protected, or dev or test environment are less protected than prod. Why can't you apply knowledge that you get from less protected environment against production environment? The bad guys are doing it, why can't we? So it's really common sense that we as humans will learn. If I see the structures and the naming conventions within the dev side, I can translate it across everything. Instead of dev, it's going to be PRD or prod or whatever, and it's going to work. So don't exclude environments, but be careful about breaking production environment. And also be careful because even dev environment sometimes, if you ask the owners, really has connections to production just called dev. Also, when we do pen testing, sometimes there are blacklists or whitelists, or only go to these IP addresses or don't go to these IP addresses. My question is that your black and white lists also published on your website, so when the bad guy comes in and it's like, I'm going to hack the system. No, this is a bad IP address, you can't go there. At some point you need to test everything. If you have problems with stability of certain IP addresses, or certain devices, make sure you fix it instead of just excluding on the pen test. And then let's talk about tools. It's important to pick the right tools. We really know how to pick wrong tools. You go and get the most expensive tool out there or open source tool. It doesn't really matter. It's what you need to do with this tool. For open source tools, you need to evaluate its function. What can it do for you? If it's a point solution, if it's a comprehensive solution, read the history of this open source tool. Read the reviews, read the challenges. Make sure that somebody used this tool against an environment that you're going to go against. It's not an overall solution for everything. Closed source tools, also nice. They are more commercial tools. They may be user-friendlier. But when you are fully delegating control to somebody else, make sure that you understand their methodologies. Some companies that provide their tools, they don't really explain. They're going to say, hey, it's going to give you a report that says, tell you if it's PCI compliant or not. Well, great, but what is it testing? It's testing everything that's PCI compliant. Okay, well, fine, but I really want to run my own test. I need to make sure that all the components that are out there actually are good components, and we test them properly. I used to have a slideshow of 10 or 12 different slides showing the attestations on, from companies and then vulnerabilities. Real vulnerabilities discovered. So one of them that is very clear in my memory is that the PCI attestation from one company said that we talked to the developer said that we have no SQL injection vulnerabilities. And when we found SQL injection vulnerability, like, well, developer didn't know about this. This was a truthful attestation. The bad guys don't care about it, and your customers that lose the data won't care about it either. When you have tools, make sure that we talk about scripting and other components, make sure you customize things. Anybody here uses Dirbuster? Anybody knows when was the last time Dirbuster was updated? 2009. But it's open source. You can tweak things. We continuously improving Dirbuster and its capabilities. We are continuously updating the list of keywords and putting new things in that. DRB, I think, stopped being maintained in 2011, which is a Linux equivalent of it. But you can still improve it. You can rewrite certain code. You can look at certain things to make it more efficient. Even if certain functions are broken, if certain components are broken, if it's open source, you can actually improve it. And you can actually mold it to what you need. And this is the coolest thing ever, because we can keep developing these things even though the owners are no longer using these things, no longer maintaining it. One thing about tools is about using default settings. And if we are using the default settings, we're going to be really assuming that this task is absolutely the same as everybody else's. If you're doing it on a third party, think about that they already probably run some kind of security scanner. If you don't customize this, if you don't put in account special conditions, for example, certain cookies that you need to put in, certain conditions, even locale of your computer and stuff like that, you may be actually testing and getting default responses, but these responses won't be as effective as the normal techniques. Same Dirbuster and Dirb actually return a lot of interesting things. In the past couple of years, we've seen several dozen vulnerabilities based on 302 web code. 302 is redirection based on certain restriction or command. So when you're running these things, you can look at the size of 302 code return. Usually it's very, very small. It's under 1 kilobyte. It basically tells you go elsewhere. So all it does is it says code 302, new location is here. What if you get 100 kilobyte response or more? Well, you know what happens. In some code, badly written, they render the full page, and then one of the last lines of code is like, oh, you're not authenticated, go elsewhere. So it actually gets you in the entire page. But then on that, based on that code 302, you're being redirected. If you look at the size of your 302 code, return code, you may see if it's not uniform across. You know, if it's couple bytes, it's okay. But if it's 10 kilobytes, 100 kilobytes, stuff like that, you're actually getting data back. So when you're doing a pen test, look at 302 codes. And it's amazing sometimes how easy it is to override these codes. All you do is strike the location and change your 302 to 200, and all of a sudden your pages start rendering. So these are the common techniques that you can use. Default tools would never do this. The default tools would say, hey, it's 302, go here. And you're going to follow that. By the way, this is Dirbuster's default function. But if you actually switch over, don't follow links, you're going to see this information. So we run Dirbuster always twice. So it's interesting how things can open up if you know go outside of tools. Using wrong tools. If you have one single set of tools like NetSys and assume that it will give you everything that you need, no. It will only give you certain functions, certain components. Understanding what the tool does is a part of your success. We use different components, different libraries, different things based on speed, based on returns, based on interaction, based on defenses. A lot of web application firewalls now reject certain automated ways. Again, going back to the defaults, there are default cookies set by lots of automated tools. Change that default cookie to something else, because that's how some tools detect your default tools. Your brain is the biggest tool for pen testing. If you're not using your brain and you're using just tools for pen testing, you're not a great pen tester, I'm sorry. You need to actually understand how things work in order to get much, much further. When you are starting a pen test, you sit down with the application owner or infrastructure owner, whoever's commissioning it, and you ask a whole bunch of questions. And when they say, no, you should know that, ask them why not. IP addresses, well, kind of makes sense. Like, what's the realm that you're testing? If you're doing an internal pen test and they won't give you subnet ranges, there are, let's see, a couple million IP addresses, 3 million IP addresses, I think, that you're going to be testing, instead of being given much smaller scope. So test much, much smaller scope. Ask for these ranges. Test the rest. But don't put much stock into this. Another clue for internal pen testing, ask for routing tables. Routing tables would be really neatly summarizing all networks that are inside. DNS entries. Why it's important to know DNS entries? Because certain DNS entries you cannot guess. You can gather them from elsewhere, like from certificates, from DNS cache, passive DNS, stuff like that. But knowing all the DNS endpoints, you may actually find things that are long forgotten. In some cases, you'll find other things. When we look at DNS entries, sometimes we find that the IP address is no longer owned by the company. Sometimes it's pointing to a different place. And the bad guys would love to take over that IP address and put something bad there. vHosts. On a lot of web servers, you have virtual hosts or equivalent. And when you look at these type of components, you may not be able to guess them. Some of them may be even internal, but if a server web server has both external and internal functionality, it's possible to make calls to that web server if interfaces are not properly bound. So make sure that you ask for that information additionally. Application endpoints. Sometimes application is there on index.html on the front page. Sometimes it's not. Sometimes it's deeper inside of the infrastructure. And if you don't know that, you may never be able to find it. But sometimes in applications, sometimes on the internet, it's an easy way to find these things. APIs. Nowadays, web applications are much, much more complex. So knowing how API work, it's much, much easier to go forward. We even ask for file structures, saying, hey, just give me all the files that's sitting in the web root, for example, in all virtual map directories and real directories. Why? Well, we can guess. Our file name guessing machine is really good, but we're not going to be as good as some other guys. Maybe we're not testing it in the right language, because if your server is in Mexico, it's most likely have Spanish file names. And we have good libraries, but we may not be able to test everything. The bad guys may guess for certain things, but pen testing is not only about guessing. It's also about getting the right things right away. Asking for logins, I already talked about it, but it's a fair game to ask for logins without admin privilege. But it's a good way to ask and shorten the wait. If you're given 1 week for a pen test and you have to request a login that takes 48 hours to approve, well, guess what? For first 2 days, you're not going to be testing the right thing. And that's going to be very weird and unusual. Here's another thing that you can ask about sharing knowledge. Ask for a demo of the application. Ask how it works and what it does. Because once you get in, you may not have a clue what it's for, or what the endpoints, or what they're to do. It's unusual, maybe. And most likely somebody will tell you, no, you shouldn't know about it. Okay, beat the system. Go on their website and watch a demo, or request a demo. Pretend to be a customer. They will give you a demo of the site, ins and outs and stuff like that. And you may learn much more about it. Before you start doing certain things, you want to do some discovery, reconnaissance. OSINT is really, really cool because when we are doing OSINT, we may find things that the company may not know about itself. We're going to go Google, we're going to look for other things. We may be in sooner than later. And the other thing is, we want to discover DNS endpoints, ask search engines, ask GitHub. Sometimes lots of information going to be disclosed on GitHub. And don't only look for keywords like company name and stuff like that. Figure out who works for that company and have GitHub repositories and see what they have inside of their repositories. Find their passwords inside of their repositories and log into application under their passwords. That's maybe part of a fair game. The dark web. The dark web is also part of fair game. There are stolen credentials out there, and there is botnet data. Now, I can caution you and tell you, never pay for stolen credentials. You are empowering the bad guys. You're creating interest for the bad guys in this particular type of data. So don't give bad guys your money, even if it's for pen test. Go to the client, to the company, and say, hey, it's out there. Make a decision, and let them do that. And if you obtain credentials for free or otherwise, don't use them beyond proof of concept. Go to a client and say, hey, these stolen credentials are on the dark web. They're still valid. You investigate further. There is a technique for some folks to use these credentials. And what you're doing, you are destroying evidence of crime. So if bad guys already use these credentials, got in, you may be erasing all forensic evidence that this account has in place. Don't do that. Go to the company that you're doing pen tests for and say, hey, it's found, you guys fix it, give me some more credentials so I can continue testing. This is fair game. Using stolen abuse data, you may be doing a huge disservice to the victim. So probes. Initially probing the network and making sure that you understand the infrastructure, services, applications, components of these applications. So you find everything that is out there so you can actually do testing appropriately. Within this, you start mapping with an application all the endpoints, all the ins and outs, things that allow you authentication and don't allow authentication. Stealth and speed are mutually exclusive. If part of your exercise is to be not discovered, you do this, but you don't do it all along. You're going to say, for the first 2 days, I'm going to be in stealth mode, see what you see. But if you have a limited amount of time to do a pen test, don't go in the slow mode all the time, because the bad guys have infinite amount of time. If you're given a week, and spending that whole week going very, very slow, you're not going to go through the entire infrastructure. It's not fair, it's not good. Within the web applications and other applications, understanding how the data flows. Asking the company, saying, okay, where does this data go? Give me a data flow chart. How many servers in end tier? Is there cloud components? What happens on the back end? It's part of understanding how things work. We talk about different environments, production and others. Authentication and authorization, very important to test. Once you get inside the application, log out and test all these things that you mapped out while inside, and maybe you get different results. Same thing for users. Make sure that user A gets moved to user B besides authentication strings, and see if user A can see user B, and so on and so on. Lateral movements escalations within web applications are very simple. For example, if you go to admin panel and see how a call is being made to make any user admin, try to repeat that call as a user to make itself admin. Believe it or not, at 50% of the time today in today's applications, it works. I can make myself admin. I just need to know how to make that call properly. So examining these things on admin side sometimes helps. Using various standard exploitation techniques works. And right now, don't think even with complex applications, you won't be successful finding these things. But more and more, we are starting to look at components of JavaScript. JavaScript is a great repository to figure out how the application is built. If you have the obfuscation of JavaScript, pulling out all the endpoints from there, sometimes you find passwords. I found in JavaScript just last week, anthem of Ukraine, links to family pictures, and links to internal GitLab of one company all in one script. So that was an interesting thing. Active Directory. Besides the standard exploitation network, look for older technologies. They're usually more vulnerable than others. Look for bad scripts. My favorite thing, once you're doing AD audit and you get the basic user access, try to look at network scripts and look for writable network scripts. It's really cool to modify a script that's being executed by all the users. And you basically let them run whatever you want to run. Sometimes these scripts are being run as admin, and you become admin. So give yourself admin privileges part of it. Look for patches or lack of patches out there. And if you have access, try to turn things on and off. Sometimes when you get inside of some of the applications, you can turn off certain components. So, we in some pen tests, you get inside of WAF and Web Application Firewall. You make an exception for your IP address, and all of a sudden, the entire all the servers are vulnerable. Networking is also extremely important. Understanding the protocols, understanding how the management platforms work, and communications. If you're not familiar with networking, especially for internal pen tests, become more familiar, because that's one of the easiest ways even to route data, becoming one of the routing points on the network by if there is a node failover setup, you can become the main node. End user devices. Keep in mind that not all devices are the same. So if there is great uniformity, look for odd things. IT devices are the easiest ones, because IT folks think that about the rules, or they test things and they leave things open. So that's really, really cool. And also look for forgotten components. I love management platforms for internal pen tests. Management platforms are usually easy, and people think, like, nobody will log into a management platform. Let me put username test and password test, or something like that. But look at these platforms also not patched all the time. Think about SolarWinds and how much headache that was. They're misconfigured, and some of them forgotten. On the recent pen test, we found a management system that somebody tested, and then they didn't like it, they didn't buy it, but they forgot to turn off the server. The demo license expired. So what we did? Well, we did something really weird. We blocked, the web application would communicate with licensing server, make sure that the licensing is intact, and obviously because it wasn't, it would tell you that the application is not licensed. Block communication with licensing server, and the application is licensed. Because it can talk, it's licensed. now you can log in because nobody changed the default logins, and now you have access to their AD credentials for admin that nobody really removed an application. So these things do work when you find these platforms, and don't get discouraged like this doesn't work and stuff like that. Even Silverlight, which is an antique thing that only works in Internet Explorer that is no longer supported, download Silverlight, make sure that Edge is running in the Internet Explorer compatible mode, and now you can get into Silverlight. This actually, we exploited one system 2 days ago, just like that. Don't forget about IoT. IoT is easy. In some cases, nobody really cares about printers on the network, but printers do store like your network passwords for scanning and stuff like that. That's kind of cool. Some companies consider printers to be their mission critical because if the company is doing 3D printing on 3D printers as a main business, their printers is their intellectual property. Their printers is their production. So now you start caring about printers. Cameras, like, okay, well, cool, I can see public areas because the cameras are supposed to be only in public areas. What if you're a bank? We see there are stories of bad guys disabling, getting on the network, disabling cameras on the bank network so they can compromise and rob the bank because all the cameras are off. They know that nothing would be recorded. Cameras are important in certain cases, but cameras are also very, very critical for people's privacy. Environmental controls, usually left unattended, but environmental controls are also interesting. As all the IoT devices, people reuse passwords. So you get into one IoT device, all of a sudden you get admin for many others. Physical access. All the control panels also can be manipulated in a certain way or even disconnected. In certain rooms, like meeting rooms, even public areas, there are now little iPads sitting or tablets that you can reserve the room and stuff like that. If you click on a couple of things, if it's not properly secured, you can get Wi-Fi password, the internal Wi-Fi password, if you're really entrepreneurial. By the way, when you somebody brings you a wine list in the restaurant, stuff like that, you can do that too and get into a restaurant network. Not that lesson. Anyways, power. Power may be underrated. You're not going to play around with power within the company, but to IT, to management, it's critical because if somebody shuts down power, there may be a critical situation. In the cloud, pen testing in cloud is rather difficult because you don't have continuous IP space. You have endpoints that somebody can build and drop at the drop of a hat, but go ahead and map all the endpoints. These endpoints can be vulnerable. Most breaches that we are seeing today, somebody created something in the cloud, forgot to tell anything about it. It's exposed, placed some data in it, somebody else found it. The mean time of finding things used to be 1 to 2 months. Now it's hours. So if you leave something exposed, things would get found really quickly. So make sure that you're ahead of it and anything that's being put out on the cloud gets tested right away. Finding management consoles, we'll talk about those as well. Code repositories, Bitbucket, GitHub, GitLab, components of Jira, Zendesk, Confluence, and others. They're all out there. They're all in the cloud. And there are so many different techniques to abuse and get data out of them. And that's part of a pen test because your goal is to get in using things around you. Forgotten credentials. We talk about bad credentials, so I'm going to kind of skip that. Couple advanced topics. SQL injection also can be done with intelligence. It's not a simple thing to do, but we can do that much deeper. Broken links, dead domains, also part of what we can use for attacks, because sometimes the bad guys can take over this domain. They can look at where a broken link is leading and use some kind of other attack. We have a technique to use web logs to understand how the application is really built. If you ingest all your web logs, mostly GET requests, POST requests are a bit complicated, but GET requests, you can play against your website without authentication or with basic user authentication. And that gives you the best ever map of the site ever. We'll find everything that's unauthenticated or has weak authentication. Try it. Your web logs is the best map to your site. Impersonations. As I'm running out of time, couple more components. Try to abuse physical access to electronic assets. Intrusion detection. As you're doing pen tests, make sure that security tools that the company has are working as well. Anti-phishing components, not only you test the users, but test the technology. Try to send a phishing email that should be stopped. See why it's not stopped. And also, same thing as anti-ransomware. Data can be exfiltrated. Can you detect it? Can your defense systems detect it? And it's part of pen test. Lastly, as a security tools testing, logging, alerting. As your pen test progresses, did anybody see your activities? Did anybody see how things were created? Don't tell the company that you're testing or internal folks to study for the test, but also don't tell them to ignore the test. It needs to be in normal environment, because when bad guys hit your network, they're not going to be, nobody going to study for the test, and nobody going to ignore it. Test your honeypots. Make sure that part of your pen test, if you have honeypots, see how honeypots respond to real attacks. I know I'm right on time, so if anybody has questions, probably afterwards. Thank you very much.